Welcome back, everyone. In this video, we're going to go over the steps that you need to take to solve a linear equation in one variable. So first thing to do is to talk about what a linear equation in one variable looks like. That will be an equation that looks like ax plus b equals 0. And when I say looks like, there could be a different variable aside from x or other than x in place of x, but it's just common in algebra to use x. The a and b are constants, so it's some number times x plus some number equals 0. And when I mean that it looks like that, I mean that it can look like that. So for example, the equation 3x plus 11 equals 13, that equation can be made to look like ax plus b equals 0, as we'll see, by subtracting 13 from both sides. Additionally, if we had 3x plus 4 equals x minus 7, this one, we could make it look like ax plus b equals 0 by applying some algebra to it. So the key thing here, or a key thing, is that throughout this section, throughout this video, you won't see any higher powers on x. So there's no x squared. There's no 5x squared minus 3 equals 0. You won't see an x underneath a square root sign. And you won't see x in a denominator of a fraction. Okay, so that's the types of equations that we will be dealing with. The first thing or next thing to do is to look at what a solution to an equation is. A solution to an equation is a number that when you replace the variable in the equation by that number, you end up with a true statement. As a really easy example, what if we had the equation x equals 5, which looks to you like it's the answer, but it's a perfectly legitimate equation. If I replace x by a 2, we get a false statement. 2 is not a solution to x equals 5. Of course, if we replace x by 5, we get a true statement. That's why 5 is a solution to the equation x equals 5. Let me give a little bit more interesting example. Suppose that 3 times x is equal to 12. If you replace x by a 4, you have 3 times 4 equals 12, which is true. So 4 is a solution. On the other hand, if we replaced in 3x equals 12, if we replaced x by 0, we'd have 0 equals 12, and that's false, which is why 0 is not a solution to this equation. Okay, so throughout this video, when I'm referring to an equation, I mean an equation that looks like this, so that I don't have to keep saying linear equation in one variable. And when we're solving, we're finding the solutions, that is the numbers that make the equations true. Okay, so as a first example, we just want to decide if the two numbers 4/3 and then 1/3 are a solution to 9y plus 2 equals 6y plus 3. And so throughout this video, feel free to pause the video and try the examples yourself before going through it and seeing what I've done. All right, so let's try. We want to see if 4/3 is a solution to this equation. So I'm going to replace y by 4/3 everywhere it occurs. Okay, now there's no more variables in the equation, and I just need to simplify each of the two sides separately and then determine if we've gotten a true statement. So 9 times 4/3 is going to equal 12. 6 times 4/3 is going to equal 8. And then doing the additions, we'll have 14 is equal to 11, and that's false. So I would say that 4/3 is not a solution to the equation. Let's try 1/3 instead. Okay, now doing the arithmetic, 9 times 1/3 is 3. 6 times 1/3 is 2. So we end up, after doing the simplification, we end up with 5 equals 5, which is true. And so that means that the solution is 1/3. And how you may see that written is inside a set of curly braces to say, okay, well, here's the solution to that equation. Okay, so the answer here would be yes for the question as posed. Okay. So how do you go about finding solutions? Fortunately, there's a couple of properties that we can apply to equations to generate a simpler equivalent equation, and those are the addition and multiplication properties of equality. So the first one, the addition property, says essentially if you have two things that are equal to each other and you can either add or subtract the same amount from both and they stay equal. And I like this rule because it's really common sense if you think about it. If you and your best friend are the same age, in 5 years, will you still be the same age? The answer is yes, pretty clear. If you and your friend have the same amount of money and you each go and buy a movie ticket for a lot of money, after you buy the movie ticket, you will still have the same amount of money if you started out with the same money. So in short, if you have two numbers that are equal to each other, you can add or subtract the same amount on both sides of that equation and you get an equal result or an equivalent equation. The multiplication property of equality is really similar. There's just a little fine print in here about C not equaling 0. If A is equal to B and C is not 0, then you can multiply by C or divide by C and the equality is preserved. Of course, if you multiplied by both sides by 0, you'd still have equality. It's just that it's not very helpful as far as solving the equation, which is why we've put the restriction on both parts. Of course, division by 0 is undefined, and so that's why we have this restriction in here. So essentially what we can do is treat equals equally is a short way of putting it. If you have two numbers that are equal to each other, you can add, subtract, multiply, and divide both sides by the same number, of course, provided you're not dividing by 0, and you will have an equivalent equation. An equivalent equation is one that has the same solutions. Okay, so the steps to take to solve an equation, this looks like a lot of writing, but we'll go through it. 3 steps. You're going to simplify each side separately. How you'll do that is by distributing to remove parentheses, and then you'll combine like terms. Once you've done that, simplified each side as much as you can by itself, we're going to use the addition property to collect variable terms on one side of the equation and number terms on the other side of the equation. Then finally, we'll use the multiplication property to make the variable's coefficient a 1. Okay, so let's try it out. With this first equation, we have 2, and then in parentheses x minus 4 plus 3 equals 1. So the first step would be to simplify each side separately. The left side, let me distribute to remove parentheses. The right side, there's nothing to do. And then parentheses are gone. And so what we'll do now is combine like terms. There's only one variable term, so it's going to stay 2x. Negative 8 plus 3 is negative 5. Okay, and again, nothing to do on the right side. Okay, so we've completed step 1. We distributed to remove parentheses. We combine like terms. Next, we want variable terms on one side, number terms on the other. Right now, there's only one variable term, and it's on the left, and that's fine. There are 2 number terms, one on the left and one on the right. It doesn't make a difference where the variable ends up. It could be on the left or right. Since there's only one and it's already on the left, let's leave it there, which means that this negative 5 should not be there. And so to undo that subtraction by 5, we're going to add 5. And of course, following the addition property of equality, we need to do that on both sides. Okay, now combining like terms again, we'll have 2x is equal to 5. Okay, now there's only one term on each side of the equation. Variables are on the left, constants are on the right. So we'll finish with step 3, use the multiplication property to make the variable's coefficient a 1. Right now it's a 2. To undo a multiplication by 2, we will divide by 2. And so we'll have x equals 5/2, a simpler equivalent equation to the original equation we had. So our solution there is going to be 5/2. Okay. If you wish, substitute the 5/2 into the original equation, do the simplification, and you'll see that it ends up being true. Okay, let's try that again. So here we have 2/3, 3y plus 6 equals 5 minus y. So what I'll do first is distribute to remove the parentheses. Let me actually pull that up a little bit, make a little more room. Okay. So then distributing to remove parentheses, we'll have 2/3 times 3y plus 2/3 times 6. That will equal 5 minus y. 2/3 of 3y is going to be 2y. 2/3 of 6 is going to be 4. And then we'll have 5 minus y. All right, so now this equation has 4 terms in it. 2 have a variable and 2 don't. So what we're going to want to do is collect all the variable terms on one side and the number terms on the other. So let me first move over a little bit. Let me recopy our equation. 2y plus 4, 5 minus y. So if we want the variable to be on the left side, which I've decided to do, then that means that I shouldn't have this minus y on the right side. So we're going to add y to both sides. Okay, and then this will give us 2y. That's combining terms. We'll have 3y plus 4. And then on the right side, just 5. Okay, that's gotten rid of that extra variable term on the right. Now we want to get rid of this 4 that is on the left side. So we will be subtracting 4 from both sides. This will give us 3y is equal to 1. And finally, y equals 1/3. So our solution here is 1/3. All right, so that is the beginning here of solving linear equations in one variable. We have more work to do, and that will come in the next video. In the meantime, let me know if you have any questions, and then have a great day.